Rationalizing the denominator means to remove the radical terms from the denominator. Now, first I'd like to explain the principles involved for using the process to show that the number is not changed. First principle, any number multiplied by 1 will be the same number. For example, 3 times 1 is equal to 3. So x times 1 is equal to x. So square root of 5 times 1 is equal to square root of 5. Principle 2, fractions that have the same numerator and denominator is equal to 1. For example, 5 over 5 is equal to 1. Or a divided by a over a is equal to 1. Or square root of 2 over square root of 2 is equal to 1. So principle number 3, any number multiplied by a fraction that has the same numerator and denominator is the same. For example, 3 multiplied by 2 over 2, which is a fraction that has the same numerator and denominator. So let's try to multiply this one. 3, we put the denominator 1. 3 times 2 is 6. 1 times 2 is 2. So 6 divided by 2 is 3. So even if we multiply this number, the number actually did not change. So we will apply these principles in rationalizing the denominator. So example 1, for example, we have 5 over square root of 3. So rationalizing the denominator means we remove the radical sign on the denominator. So what we need to do is to make this into a perfect square, and then that will remove the radical. For example, if we multiply this one by square root of 3 and square root of 3, so the numerator will become 5 square root of 3, but the denominator, we multiply this one with this one, it will become square root of 9. So your answer will be 5 square root of 3, but square root of 9 is 3. So you were able to remove the radical sign from the denominator. Example 2, 2a over square root of x. So it doesn't have to be just number. You can also remove the radical sign even if it is a variable. So square root of x, so we multiply that by square root of x. So we have to multiply the top as well with square root of x. So 2a times square root of x will be 2a square root of x. So the denominator will be square root of x squared. So it's still the same, 2a square root of x. Square root of x squared is x. So example 3. So now example 3 is a combination of a number and a radical. For example, m plus 1 is divided by over 3 square root of 2. So 3 doesn't have a radical sign, so we only need to multiply square root of 2. Square root of 2, square root of 2. So m plus 1 times square root of 2 will be m plus 1 square root of 2. Now the bottom will be 3 square root of 4. So we just copy the numerator, m plus 1 square root of 2. So square root of 4 is 2 times 3 is 6. Example 4. So for example, the denominator is not a square root but a higher order of radical signs. So for example, c over cube root of 5. Cube root of 5. Now to make this into a perfect cube, we have, this is 5 to the first power, so we have to make it into a cube so that the cube root will cancel it out. So we have to multiply that by cube root of 5 squared. And then, of course, we have to do it at the numerator as well. So this will become c times square root of cube root of 5 squared. But the bottom will be, so cube root of 5 cube. Cube root of 5 cube. So 5 to the first power and 5 squared. If you add it, it will become 5 cube. Now cube root of 5 cube will be 5. So the radical sign is removed. This will still be the same. C times the cube root of 5 squared. That is 5 squared. Example 5. Sometimes there's a combination, like for example, m over cube root of ab squared. So in here, we want them both to become cubes so that it will cancel out the cube root. So what we need to multiply with that one is, so this is a to the first power, so we need a squared. This is b squared already, so what we only need is b to make it into a cube, b to the first power. So we need to multiply what is in here. It should be the same on the top, so a squared b. So m times this one will be m a squared b, but the bottom will be, this is cube root. This is cube root. So this will be cube root of a cube b cube, a cube b cube. So this will be canceling out. This will become ab, because the cube root of a cube is a and the cube root of b cube is b. This we just copy m and then the cube root of a squared b. Example 6. So it doesn't have to be square root and cube root. It could be higher, like 6. Let's say let's change it into an x. Too much m. X over fifth root of y squared. So now this is a fifth root. It had to be raised to the fifth power. So what we need to multiply with that one is the fifth root of y cube. And then, of course, we have to do it on the top as well. Fifth root of y cube. So we multiply this one and this one, it becomes x times the fifth root of y cube. The bottom one would be the fifth root of y to the fifth, because y squared times y cube will be y to the fifth. So the fifth root of y to the fifth will be y. And we just copy the numerator, fifth root of y cube. Now, example 7. It can also be a combination. So, higher number, so 2, like the 8th root of m squared n cube. So we multiply. So we want this to be 8. So what we need to multiply, the 8th root of, so to make this 2 into 8, m to the 6, we need to do it m to the 6. This one is 3. To make it 8, we need n to the 5th. So, and then we copy this one in the numerator, m6 n to the 5th. So that will be 2 times this one, the 8th root of m to the 6 n to the 5th over the 8th root of, so m squared times m to the 6 will be m to the 8th. N cubed times n to the 5th power is n8. So the answer will be, we just copy the numerator, 2 the 8th root of m to the 6th and to the 5th. So this will be mn only, mn. Before we proceed to the next example, I'd just like to introduce to you conjugates. For example, conjugates are a pair of binomials that are the same numbers, but they have opposite operations. One will be addition, the other is division. For example, x plus y, and the other is x minus y. If we multiply this two, so x times x will be x squared, x times y will be xy, negative y times x will be negative xy, and then negative y times positive y will be negative y squared. So if you combine this, will cancel out. So what will be left will be x squared minus y squared. So for this principle, we can multiply our denominator with a conjugate, with its conjugate, if it's a binomial, and then it will end up squared. Thus, it will remove the radical sign. So let's proceed with the next example. For example, we have number 8 is 3 over x minus square root of y. So what we have here, so we have two numbers. One has a square root sign, and the operation is as subtraction. So we need to multiply that with the same number, but with the opposite operation. This is subtraction. We need to multiply it with addition. So whatever is in the denominator should also be in the numerator. So if we multiply this, so this will be, we just copy. This becomes x plus square root of y. But in here, so same as in here, we will just square this one and then this one, and it will be the answer. Or let me show you the actual multiplication. X minus square root of y times x minus the square root of y. So this becomes x squared. This becomes negative x square root of y. Sorry, this is positive. X times x is x squared. X times negative square root of y is negative x square root of y. So we multiply this one with this one, it becomes positive x square root of y. Positive and negative will be negative. Square root of y times square root of y will be square root of y squared. So this will be cancelling out. So your answer will be x squared minus square root of y squared is y. So your denominator no longer has a radical sign. So it's rationalized. So the next number, it can also be numbers and make it more simple. For example, we have f over square root of 2 plus square root of 3. So this is a plus. We copy the number square root of 2, square root of 3, but this time we put subtraction. And then whatever is in here, which should be the same as on the top, square root of 2 minus square root of 3. So we just multiply the top, f times square root of 2 minus square root of 3. But in the bottom, like what we did in here, this will be squared. So the square root of 2 times square root of 2 is square root of 4. It becomes 2. And then square root of 3 times square root of 3 is square root of 9 is equal to 3. So, and then we put the negative sign. So we just copy this procedure into these two numbers. So we have the square root of 3, 2 minus 3. Oh, so this is so we can proceed. This will be negative 1 f square root of 2 minus square root of 3. So this one divided by negative 1, it will be f square root of 2 minus square root of 3. So that will be your final answer. So sometimes it can be a trinomial. Let's say s, this is s. Let's say s over x plus y plus square root of 5. So we have here a trinomial. So what we will do, we'll just combine this one as a we treat it as a single term, like a monomial. So this will be we have to find the conjugate. So we just copy this one, x plus y, as a single term. So this is addition, we just make it into subtraction times the square root of 5. And then this, whatever is in the bottom should be the same as on the top, x plus y minus square root of 5. So these are now conjugates. So copying this procedure, what we will have here will be, so this becomes x plus y squared, and then square root of 5 times square root of 5 is square root of 25 or 5, and then copy the sign is negative, and then we just copy the we just multiply this one with this one. So s multiplied by x plus y minus 5. So this will be multiplied, everything will be multiplied with that one. So this is your final answer.